All right, so Jessica goes to a garden center to buy potted plants for her garden. Her favorites are pansies and mums. She wants to spend no more than $30, and she wants to buy at least 8 potted plants. So go ahead and grab a highlighter out of the middle black caddy, and I want you to highlight that she wants to spend no more than $30, and she wants to buy at least 8 potted plants. So we're going to write a system and create a graph to model all the combinations of pansies and mums that she can buy. So we want to let X represent the number of pansies. So I'm going to go ahead and label this as X. And we want Y to represent the number of mums. So we'll label this as Y. So the first set of plants, the pansies, that's going to represent X. And the second set of plants, the mums, that's going to represent Y. So we always write our inequality. AX plus BY is something greater than, less than, greater than, equal to, less than or equal to a C value. So we're going to fill in the A, B, and C, which the C is our total amount. So let's start with the pansies and the mums. So we want to buy X pansies, so 1X plus 1 mums, so 1Y, and we want to buy at least 8 potted plants. So we have to have more than 8 plants. We want to buy at least 8, which means we can have more than 8. So we're going to use the symbol less than, or sorry, greater than or equal to. So greater than or equal to, and then since we want to buy at least 8, the total has to be 8. So 1X plus 1Y is greater than or equal to 8. Now, that's the total number of flowers that she wants to buy. Now let's talk about the price. So the price of the pansies is $5. So we'll have 5X plus the total amount for the mums is $2, so 2Y. And I want to spend no more than $30, which means I can spend exactly $30 or less than $30. I cannot spend more than $30. So we have to use the less than or equal to, and then our total is 30. So inequality 1 is all about the number of flowers. So the pansies plus the mums is greater than or equal to a total of 8. And then we have $5 per pansies plus $2 per mums is less than or equal to the total of $30. So now we're going to go ahead and graph each of these inequalities in Desmos, and then we're going to identify the X and Y intercepts of each boundary line. So here's what our inequalities look like. So we have 1X plus 1Y is greater than or equal to 8, and 5X plus 2Y is less than or equal to 30. So let's start with our first inequality. So it looks like our y-intercept is 0, 8, and our x-intercept is 8, 0. So for inequality 1, the x-intercept was 8, 0, and the y-intercept was 0, 8. So that means for inequality 1, I could buy 8 of the pansies and 0 mums, or I can buy 0 pansies and 8 mums. So those two would be a combination that would make the first inequality true. So the second inequality, we're going to identify our x and y intercepts. So now I'm looking at the second inequality line. So our x-intercept is 6, 0. Our y-intercept is 0, 15. So another combination to make the second set true. Intercept. So it would be 6 pansies and 0 mums, or 0 pansies and 15 mums. That would be a combination to make the second inequality true. So we already graphed the inequalities in Desmos. So we'll just put a check and we'll say C Desmos. That's where we were identifying our x and y intercepts. So the next question says, what do the 5x and the 2y represent in the inequality? So if we revisit up here, it said $5 for the pansies and $2 for the mums. So the 5 represents the cost of the pansies and 2 represents the cost of the mums. All right, so the next question, what combinations of pansies and mums do the point 210 represent, and does it meet Jessica's requirements? So x represents the number of pansies, y represents the number of mums. So according to our point, we're buying 2 pansies and 10 mums. So looking at our choices, it either has to be C or D, so 2 pansies and 10 mums. It can't be A and it can't be B because those are not in the correct order. So now we're going to test this solution. We're going to see if this is a true solution. So it's either got to be in our dark shaded region or it's got to be on one of our boundary lines that's a solid line. So notice that it is on our solid line. So yes, it is a solution. So she can buy 2 pansies and 10 mums, which means she's buying at least 8 plants. So she's buying a total of 12, and she's spending no more than $30. So the answer would be C, because yes, it is a solution. It's on the boundary line. So it is a solution if it's on the solid line. We've got one more set to check. So x represents the number of pansies. So this is saying 4 pansies and 8 mums, which means we have to eliminate A and B again because those are not in the right order. Pansies comes first, mums comes second. And then we're going to graph 4, 8. And we're going to see if that's in our dark shaded region or if it's on the boundary line. So our darker shaded region is up here. It's not in this portion, which means it's not a solution. Not in the darker shaded region and not on the solid line. So even though it's 4 pansies and 8 mums, it's not a solution. So our answer would be choice D, because no, it is not a solution. All right, so the next question says, what combinations of pansies and mums are solutions to the system? So let's go back here. We're going to look at our graph. So it's not in this shaded portion. It's not in this shaded portion. It's in the darker shaded portion. So all of our solutions are located in the darker shaded region. Our solutions also are located on any of the solid lines. So if there's a point in the darker shaded region or on that line, then it is a solution. And the last question says, are there points in the solution region that are not reasonable for this real world situation? So let's look over here. So the point, -4, 15, that is in our solution region. But can I have -4 plants? No. So any of the points that are in the darker shaded region that are negative, even though they're in the darker shaded region, they're technically not solutions because we can't have a negative number of plants. So yes, there are some points in the darker shaded region that are negative, which are not solutions, because you can't have a negative number of plants. So even though the points are in the darker shaded region, if they're negative, they don't make sense for this problem because you can't have a negative number of plants.